You know, every single time you click a link, stream a show, or send a message, it all hinges on one critical piece of information. It's this sort of digital address that literally makes the internet work. And your device, it's using one right this second. So today, we're going to break down the IP address. I mean, really think about it for a second. Every time you're online, you're just slinging data across this massive global network with billions of other devices. So how in the world does your computer know exactly where to send that funny cat video? And maybe more importantly, how does that video find its way back to your screen and not, your neighbor's? Well, the answer lies in a unique digital address. And I mean every single device that's connected to a network, we're talking your phone, your laptop, even your smart fridge, gets assigned one. This little address is the absolute key that makes all of this communication possible. So, what exactly is this address? Let's dive in and see how it basically acts as the internet's own personal postal service. It's called an IP address, which is short for Internet Protocol Address. Now, protocol is just a fancy word for a set of rules. And in this case, it's the rulebook for how data gets addressed and routed across the internet. Its main job, its whole purpose, is to give every device on a network its own unique ID. Honestly, the best way to wrap your head around it is to think of it just like a mailing address for your house, right? If you want to get a package, you have to give the sender your specific street, city, and zip code. Well, it's the same thing on the internet. If you want to receive data, your device needs an IP address. It's really that simple. Now, here's a little detail. IP addresses have actually changed over time. You'll mostly hear about two versions. There's the classic, IPv4, and then there's the newer, much more complex IPv6. For our purposes today, we're just going to focus on IPv4, because once you understand its simple structure, you've pretty much got the key to understanding the whole system. But okay, here's where it gets really, really interesting. Unlike, say, a serial number that's stamped onto your device forever, this address isn't permanent. It's actually an address that moves. Yeah, see, unlike a serial number that's literally etched into your computer's hardware, an IP address is what we call a logical address. And what that means is that it can change. In fact, it does, all the time. And this table right here just illustrates the difference perfectly. A physical address, like your computer's MAC address, that's like its serial number. It's permanent, it never changes. But a logical IP address, that's more like a hotel room number. Think about it. When you connect to the Wi-Fi at a coffee shop, you get assigned an IP address for that network. Then you go home, you connect to your own Wi-Fi, boom, you get a completely different one. The address is tied to the network you're on, not the device itself. So what does one of these IPv4 addresses actually look like? Well, it follows a very specific set of rules. It's always 4 numbers, and they're always separated by dots. Each of those numbers is called an octet. And here's the key. Each octet has to be a value somewhere between 0 and 255. That's it. No letters, no weird characters, and absolutely no numbers higher than 255. Okay, enough theory. Let's get a little more practical. You can actually find your device's current local IP address in, just a few seconds. So if you're on a Windows computer, finding it is super simple. Just open up the command prompt, type ipconfig, and hit enter. And if you're on a Mac, don't worry, it's basically the same thing in the terminal, but you'll use the command ifconfig. Either way, that number you see next to IPv4 address, that's your digital home address, at least for this session. All right, you've learned the rules, so I think it's time for a little pop quiz. Let's see if you can spot a fake. Get ready, take a close look, 'cause here they come. Okay, so here are 5 potential IP addresses. Now, based on the rules we just covered, 4 octets, numbers only between 0 and 255, which of these do you think are valid and which are totally impossible? Go ahead and pause here if you need a second to figure it out. All right, you got your answers locked in? Let's check the results and see how you did. Let's break this down. So A and C are totally valid. All their numbers are perfectly within that 0 to 255 range. But B is invalid, right? Because 256 is just one number too high. D is a mess for 2 reasons. First, it has 5 octets, not 4, and one of those numbers is way over the limit. And E is invalid because it's got a letter in it. Remember, IPv4 only uses decimal numbers. So how'd you do? Okay, so we know how to find it, we know how to check if it's valid, but why does this string of numbers matter so much? What's the big deal here? Well, our source material from NASO Academy really just says it perfectly. Every node in the computer network is identified with the help of IP address only. That's it. It is the single point of identification.
Without an IP address, there would be absolutely no way to tell your laptop apart from the billions of other devices online. It's the one thing that ensures the email you send actually gets to the right person, and the video you want to watch finds its way back to your screen. It is, without a doubt, the fundamental addressing system for the entire internet.
So, in the end, you can think of your IP address like a digital passport. It's temporary, it changes depending on where you connect from, but at any given moment, it tells the network exactly where to find you. So, maybe take a moment to think about it. What network are you on right now? And what story is your IP address telling?